Good day and welcome to my channel where we make structural engineering design simple and easy. My name is Olodukonyedi and I'm your host. I want to say welcome again to another beautiful year, and we have a lot to do this year. I want to appreciate everyone who has been subscribing to my channel. I really appreciate you, and all who have been sending comments and have been asking questions. We really appreciate that. Please keep it coming, keep subscribing, keep liking our channel. That is the only way you are telling us that you appreciate what we are doing. And those who are yet to subscribe, please hit that subscribe button, and when next we put up any video, you will be notified promptly. I want to say thank you once again. We got some people that made payment for our online course. Anyanwu Joseph, I appreciate you. You said, I made payment for the tutorial and couldn't access it. I tried creating an account and I got a message, access denied. We are working on that, but if you check your email, we have sent the access to you. Please click on that link and we will grant you access to the course. I appreciate everyone who has purchased our course. More course will be coming up, more detailed in different areas of design. So Joseph, once again, I appreciate you. Please check your email. We've sent you a link to access our course. Please, you can send us an email. Send us an email and we will tell you how to get the course done. We are having some issues with Seller, the platform we uploaded our course on, but there's another channel we are using. Please send us the email and we'll send you our second channel of accessing the course. Thank you again, once again, Joseph. And we also got another question from Ezekiel Mukoro. You didn't tell us where you are commenting from. You said, thanks so much. Can I get an explanation on how to design steel truss on concrete columns and beam structure? Yes, we are planning of that. Will be when we start putting out tutorials on steel design. That will be the next phase of our training. So please just pay attention to this platform. And if you've not subscribed, please hit that subscribe button so that when we put up our steel designs, you will get notified. So after protastructure, we'll be teaching on different softwares. We are planning of going into Revit structure. We are planning of doing tecla, protastructure, Revit structure. Those are the things we are looking out in this first quarter to push out. After we've done this protastructure, the next software we are looking at is either we are doing Revit structure or tecla. Tecla is very good for steel design. So VJ has been asking me about column stud, if protastructure does it. It does it, but it's not as effective as tecla. So but once we put up videos on tecla, then you see how you do your steel design very well. So please pay attention to this page. We'll soon start putting out that soon. We got another question from Godwin Alabi. He said, good morning, sir. I am Godwin Alabi from Kaduna State. Please, how do you introduce construction joints when using protastructure. If I get your question correctly, I don't know whether you're asking of expansion joints or construction joints. So as for expansion joint, we've done that before. Please check our previous video. But if you're asking for construction joint, protastructure does not really do that. Construction joint, because it's not really a structural element. It's just a process of constructing. So if you must do that, where you want to create your construction joint, let's assume you want to create your construction joint, so it's not really a structural element. When you create, it's like you creating kicker on your structure. You can either do it 75 mm or 100 or 150 mm. Then you create a connect where you can connect this concrete to this concrete that is already existing. This one, because most time you can't cast all your structures at once. So what you do is to create a construction joint where the new elements come in. You can either create your body, you can board your structure here with this kicker, or the extent that you've extended it out to connect with the new concrete coming. So it's not really structural thing, it's just understanding the process of construction. So protastructure does not really do that. You just need to put in your construction joints manually. So Godwin, if this is what you are asking, please let us know. But if not, please comment, then we look for ways to solve that. So also we have Ajay Malofin Abiodu David. He said, I am David Ajay Malofin from Lagos State. I appreciate the good work you are doing. Keep it up, sir. I appreciate you, sir. Abiodun, I really appreciate that. Please keep those comments coming. These are the encouragements we are looking for. And if you've not subscribed and you've been gaining value from this our videos, please, the only thing you can do for us is to subscribe to this channel and like our channel, and that's how you show us your appreciation. So thank you very much. Today we'll be talking about raft design. So please check our previous videos. We will not be talking about the substructure. We've already done that. So please check our previous video. We will just move straight down to the foundation. So that is what we will do. We will move straight to the foundation. So if you don't understand how we got all this, please check our previous videos. But if not, we have our online protastructure course still running, just 5,000. Send us an email and we'll send you the link to the course where all this from A to Z was explained in detail. So thank you very much. Let's proceed. So if you want to design a raft foundation, you can either design it as a pad, the normal foundation. If the soil is good, you can design it as a pad foundation. But if if it's becoming an high rise, multiple floors, it's no longer economical to design as a pad. That is the reason why we either use raft. But if it's becoming multiple high-rise skyscrapers, it is very much advisable for you to use a pie foundation. So we've discussed about pie. Please check our previous videos. We've discussed about pies. Check them. But today we'll be discussing about raft. Raft is when you can use raft when your soil is not too good for pad. Then you use raft. Or if the area you are building is waterlogged, if there's water in that area, if you are digging and you are seeing water in the foundation, it's advisable for you to do a raft foundation. So those are the reasons. And if the load is much, and if you use pad, it will be very large, it's advisable you use raft. So to do that, go to story 0. When you get to story 0, this is what you will have. This is what you will have. So the first thing you need to do for your raft design, is to create your raft beam. Then you put your slab before you do any other thing. And to determine the depth of your slab, let's look at this structure. Normally, if you are using a pad, you may excavate 1 meter downwards, depending on the soil. If you excavate 1 meter downward and you lay your foundation, then you may give 450 from the ground level to your DPC. So with this, if you want to put your beam, you must put a beam that at least 450 above the ground. Then you can either push, if 450 above the ground, then you can either push 550 if you want the length to be 1 meter, the length of the beam to be 1 meter, so that at least whatever you do, this rising from the ground, if you use 450 as your raft, there won't be any height above the finished ground, the final ground level. So that's why we use deep beams at times, maybe 1.2, 1.5. At times we can do a raft, depending on the load that is coming, 1.5 meter, or we can do 1.2 meter or 1 meter. But whatever you do, the length, the depth of your beam, at least 450 must be out of the ground, at least, depending on the area you are working on. Some may be higher, up to 600 mm above the ground, or a minimum, minimum should be 450 above the ground. You can either play with 300, but the fair enough amount is 450 above the ground. Then the rest should be inside. So we can choose 1 meter, so that you have 450 below the soil, which is fair enough. Or you can do 6, depending. You can do either 6 meter, 600 mm inside, and you play with it. So that's how we determine the size of our beam to put inside the ground. So you collect your your beam 230, you can say by 1000, and we get it 1000. By 1000. So if you need to check your architectural drawing, the ground floor of your architectural drawing should be what you are using to create the area of your raft. The area of your raft is determined by the architectural ground floor level. So what I'm doing, I'm following my ground floor level. Yes, this is my ground floor level. So this is what we have. This is what we have as our floor level. So after this, what we need now, if you see 230 by 1000, we can either do 1200 depth. It all depends on what you want. So we go to slab. Let's pick one. Let's make our concrete cover 50, thickness 150. Then please pay attention to this. We'll come to relative level. Please pay attention. This is very, very important. Relative level. If we look at this point, we already said our slab, our beam is 1000. But if we just place our beam, okay, we'll do something so that you see it. So what we need to do is we need to take the floor, our slab, from ground floor to the top of the beam. So we minus 150, so it becomes 850. So this relative level here, we will now put 850. Very important. If you don't do this, you miss it all. So let's see what we have done. Let's go to view, let's say arrange, and we do okay. Good. So if you look carefully, if we change this thing to, let's say we do this next one, and we change it to 0. Update. Are you seeing the difference? If you look the difference now, this 0, it starts it from the 0 mark. It starts from the bottom. But if you now say 180, it will take it up. It will now take it up for you. So I hope we get this clear. So with this now, let's take this out. Okay, we can now right click and take property and match the property. Okay, beautiful. So this is what we have. So please pay attention. Let's assume if your depth of the beam is 122, simple, you just minus 150 from it, and this will become your relative level, whatever it is. Even if it is 515, you just minus this and this becomes your relative level. Or if we say 1005 and the depth of the beam is 200 and the slab is 200, so this is how you get this. Very, very important. So just pay attention. We've done this. What we need to do next is we just need to introduce wall load on it. Please check our previous design, and we've already explained all this. We will not be explaining it here. We will not be explaining that here. We will not be explaining that. If you want more, please buy our course. Just send us an email and we will give you the direction of how you can get the course. We've explained all this. So if you look carefully, we've introduced the wall load on it. So what you need to do now, please pay attention, is go to this. Before we do all this, go to settings, or two ways. Before you do this, go to analysis, building analysis. Very important, please pay attention to building analysis. Now we come to building analysis, come to edit material. When you get to edit material, we've done all this, we will not explain much. Come to foundation. This foundation, click here, check, please pay attention, check your Y12. You can check Y16, Y20, but very important, Y12 for the slab. If you don't include Y12, it will just be picking 16 and so like that. So very important, pay attention to that. You can close this. And so what we need to do now is to come to this slab strip. When you do that, if you see this analytical slab strip, that's not it. Come to FE strip. FE strip, come to X and you change it to 1. When you come here, if you look this is span strip, this is FE rib strip. If you are doing a rib slab, this is what you use. And if you are doing a flat slab, these are the things you use. But if you are doing normal stuff like this, you take this first one. So hold it down, then you draw your strips. After you are done with your X, come to Y, change it to 1. So we are done with this. We are done with that. So what next do we need to do? Come to analysis, come to FA raft foundation analysis. Normally the default here is 50,000, but what we need to do is to change this to 5,000, or click pick here. It will show you different upper and lower limits. These are the upper limit for loose sand, for medium dense sand, and all this. So since our soil for raft is not too good, if it's not too good, then we need to pick the lowest one, which is this, as 5. We just say 5,000. So that's how we include this. Then if you come here, your slab, let's assume your allowable pressure, bare soil stress pressure, depending, let's say it's 100. So come back here, click on, we can check all these, check them, and we click on raft mesh analysis. Click on it, allow it to process. Good. Come to generate building. Click on generate building. And it has finished generating. You close. We'll come to this place, allow it time, it will process. After you close, it will process and give you what you want. It has finished generating. Come to analysis post processing. Click on that. Beautiful. So we have done what we want. Once you get here, once you just click on draw slab strip, it will bring it up this way. So please, if you check properly, I will show you something. Normally on this page, what we are after is to see if the pressure is above our soil pressure. That is what we are only checking here. So how do we do that? So what we need to do here, let me bring it up. I need to see something. Okay, what we need to do here is, if you come down to soil pressure, click on soil pressure. When you click on soil pressure, come to this combination, the combination, this, click on this combination, and you click standard contours. Please let me take that again. First thing, you click on draw slab, click on this your on factor service load of G plus Q, then come to soil pressure and click on it. So if you click on standard contour, it will show you what you need to do, If you look carefully here, let's increase the scale. Let's increase it. So if you look very well here, at this blue area, it means the pressure is not up to pressure, but at close to the extreme. We are getting very close to 98, which is close to our soil pressure. Our soil pressure, which is close to our soil pressure. Yeah. So this, with this design now, you can go away with it because it's almost negligible. The pressure is almost negligible. Either you introduce an apron or you introduce more reinforcement at this edge. But with this now, if you look at your, okay, let's see, increase the size. If you look carefully, we're having at this extreme 98.7 the pressure. This is the pressure we are having using G plus Q. So it's less than, and we can introduce reinforcement. We can either say, okay, what reinforcement we need. This is where you, if you click on this the reinforcement, it will be showing you. This the reinforcement, it will be showing. This the reinforcement, 1,000. If you check carefully this extreme, anywhere there is red, this is what you use, and this is it. But majorly what we need here is our soil pressure. Majorly this is what we need, and we are okay with what we are seeing. We can close and we say yes. And we say yes, this is what we need here. This is what we need. Okay, we close. So we've done that. You won't see any reinforcement yet. You will not see any reinforcement. If you want to see the reinforcement, you come to this icon, arrange steel beam. You can click on it and click on update steel bar. Once you click, you have to, it's telling us that FS2 section insufficient in support. You say okay. So if there's an issue, it will tell us, and we click on anywhere there's an issue, it will tell us. What you need to do is, if as it's telling you this, it shows that the section is not okay. What I will do is to close. Once it's showing me that, what I will do is either to increase, I will either increase my thickness, or I break my span. I break the span, or two ways. Either I increase my thickness to 200 on this slab, or I introduce beams to break the spans that are very, very, very large. That is what I will do. That is what I will do. So this is how you do your design. If you look at it, it's already doing the designs for us. So it's either you just introduce, click down, hold down your shift, and you click, right click, and you can say properties. I will come to height, we say 200. Yes, 200. And we say okay. So it automatically change everything. Changes everything now. Yes. And we can save our Okay, we can either update, let's update still this one. Okay, what we need to, if after we've done that, increasing it, we'll go back to analysis, building analysis, run analysis, and we run analysis. So we allow the analysis to run. Allow the analysis. So after you run that analysis, come back here, same process, run your analysis. Same process. Close. And allow it to run.
Sam has crazy hair. Sam is vegan. Sam sleeps 5 hours a night. Sam lives in the Bahamas with 10 roommates. Sam is 29 years old only, but Sam has $22 billion and he wants to donate all of it.
Okay, and we are here. Okay, so this is it. Close, so close. Okay, we'll come to okay, we'll close and we update. So this is what you do. If it's still giving you, you should break the span, make it smaller. But this is how you design for your raft foundation. This is how you design for your raft foundation. If you still have, we'll put a stop to the video here. And if you have any question relating to this, please tell us where you are commenting from on the comment section, and we'll be glad to respond to you. Until we come your way next time, remain blessed. Thanks.